Quick, graph y equals 3/2 times the square root of the quantity, 36 minus x squared, by hand, 2 different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed any time. So let's go ahead and graph this. The first way is going to be using x and y intercepts. So the x-intercepts occur when the y value is equal to 0, but we only need to concern ourselves with this expression because the 3/2 will not make any difference there. So we're going to set 36 minus x squared equal to 0 and solve that for x. Adding x squared to both sides and taking the square root of both sides, making sure we get plus or minus both square roots. X is equal to plus or minus 6, and these are our x-intercepts with a y-coordinate of 0. So we'll plot those 2 points. Next, we'll look at the y-intercepts. That occurs when x is equal to 0. So substituting 0 for x, square root of 36 is 6, times 3/2 is 9. So our y-intercept is at 0, 9. We need to connect these points with a rounded curve, because normally this is a semicircle. Notice it is not a semicircle, but comparing it to the parent graph, you can see that the y values in blue are multiplied by 1.5 to get the y values in green on all points. Second way is using a table. So we'll go ahead and look at what's inside the radical, and we're going to be using these 3 values for our x. And we're going to need to multiply each y value by 3/2 because of that coefficient there. 0 times 3/2 is unchanged, so 6, 0. 0, 6. 6 times 3/2 is 9, 0, 9. And again, 0, we're going to get negative 6, 0. Connect with a curved graph. Again, it is not a semicircle. You can see that compared to the parent function. Now you try one. Graph y equals 2 times the square root of the quantity, 25 minus x squared. Use either method or both just for the practice. Press pause to do this and then resume when you're finished to check your answer. And here's our answer.